Okay, now I think I am audible, right?
Yes, sir.
Okay,
Yes, sir. Okay, sir.
Yes, sir.
okay.
Yes,
Your
sir.
voice is also reaching.
Okay, sir.
Okay, I'll do. We'll do here.
Yes, sir.
Okay, so you wait for 1 minute. I'll shut down all those things and I'll come. Meantime, whatever problem we discussed in the last class, na, you open that and try to write the data. We'll discuss the solution.
Okay, sir.
Okay, so I think I'll pin this. Okay, board is also visible, right?
Yes, sir.
Yes,
Okay,
sir.
okay, it is already in recorded mode. Okay, right. Okay, so now whatever problem we taken up in the previous class, now we'll see the solution for that problem. So what is the problem? The problem is on fluctuating loading, and then whatever data he has given, you write down the data first. So you have a bending bar, which is fixed at this end. It is subjected to a force E is equal to minus 50 newtons plus 150 newtons, and this distance is 100 and this distance is 150. Then what he has given is, for this SUT is equal to 600 Newton per mm square and SYT equal to 380 Newton per mm square. Then factor of safety is given it as 2 and notch sensitive factor given it as 0.9. Then he asked us what is D. So for that he has given this fillet radius is 0.2 D, this diameter as D, this has 1.5 D. Okay, and also the expected reliability is 90%. Expected reliability is 90%. That is the problem. Right? Okay. So how will you proceed this problem? Here the load is fluctuating. So when the load is fluctuating, whether you are designing for a finite life or infinite life, you need to use different criteria. So that is Goodman. So out of all those criteria, we need to use Goodman's criteria. We need to use Goodman's criteria, which is what you can say less complicated and also less conservative and somewhat accurate. Accurate method when compared to Soderbergh and Gerber's method. So that's why we'll use that. So in order to use that one, what you need to do is you need to construct what is the modified Goodman diagram. To construct that Goodman diagram, what you required is you required, so your modified Goodman diagram is something like this. So on the horizontal axis, first you need to construct your yield line. So which is joining SY to SYT, something like this. Then you need to have SE here, SU to here. So by joining SU to SET, that is your Goodman's line. Then whatever intersection point is there here, so this is going to be your modified Goodman diagram. So if I take A, this one as A, this one as B, and this one as C, A, B, C, if I take this one as O. So whatever region, this region is there, so this is our design region or design point region for the problem. Then again, because you have two unknowns, we'll construct one more line. We call it as a load line, OE, and the slope of this line is theta. This theta is nothing but your tan theta is equal to your sigma A by sigma M. So this is the equation which will give you the theta value. So that means this line will give you the relation between sigma A and sigma M. That is the only thing. Then if I project the point to here, so this is the SC value and this is the your SM value. So that is strength corresponding to mean stress, combination of mean and amplitude stress. These are the strengths. So now we need to construct this modified Goodman diagram. So to do that, we require this SE value. SYT is already given. Then we need to identify what is this design point. So design point, we need to identify this design point and corresponding values of for SM or you can take sigma M or SM because it is strength. We'll take this one as SA and this one as SM. You need to identify what are these values also. So the first point what we need to do is we need to calculate what is SE. We need to calculate what is SE. So for the SE, so the procedure is same. What we did in case of previous problems, here also we'll follow the same thing. So what is the formula for our SE? SE is equal to KA into KB into KC into KD into KE into KF into SE dash. KA, KB, KC, KD, KE, KF into SE dash. Since he specified the material as a steel, 40 C8 he has given, right? So for a 40 C8 steel, and he said it is a machined or what it is? Is it a machined one or a forged one or whatever it may be? So first thing is you need to see it as cold drawn. The beam is made of a cold drawn steel. So whatever it may be, but for any steel, for SC dash is nothing but 0.5 SUT. SUT is given, so I can compute SC dash, which is nothing but 0.5 into 600, which is 300 Newton per mm square. Then I have to compute Ka, Kb, Kc, all these parameters. Ka, surface finish factor. So now, if you use empirical formula A into SUT power B for Ka, for a cold drawn surface, so what are the values of this A and B, you tell me? From the data book, what is the values for a machine drawn?
4.51 sir, A value.
A is 4.51 SUT is 600 to the power B is minus
265.
0.265. So compute what is Ka value.
Point 827, sir.
Point
827.
867. Then what about KB?
Sir, 82, sir.
827,
0.82.
sir.
Okay. 0.82, right. So then KB. So here we don't know the size. We need to calculate the size. So therefore, to find out the KB value, what we will is, we'll assume that the size D will be within that range 7.5 mm to 50 mm. In that case, we'll take KB as 0.85. Then Kc, the load factor is going to be 1 because here it is subjected to a bending. We need to take it as 1. Kc is 1. Similarly, our temperature factor Kd is also 1 because it doesn't mention anything about temperature. Then what is Ke? Reliability factor. So expected reliability is 90%. So for 90% reliability, what is the reliability factor?
897, sir.
0.897. Then correction for the miscellaneous factors, we'll take it as 1. Kf is 1. So now we need to substitute all this into this equation and we need to compute what is SE. So finally our SE is equal to 0.82 into 0.85 into 1 into 1 into 0.897 into 1 is equal to, into 300. SE dash is 300. So that is going to be our SE. This SE what we'll call it as fully corrected entrance limit for the component. Okay, now you tell me, calculating that value, you tell me what is that?
189.16, sir.
180?
9.16.
189.16 MPa or Newton per mm square. Is it visible or I'm going beyond the point? Okay, I think it is beyond the point. Just what I'll do is, okay, I think now it's okay. 189 point, okay, still it is not visible, I think. Okay, so you take this value and SE is
Visible, sir.
189.16. Okay, now I got SE value. Then SUT is SYT and SYT and SUT is already given to me. Then if I am able to find this value, that is this load line, the ratio of sigma A by sigma M, then I can use the two equations to solve this problem now. So what I'll do is, I'll rub off this one. Now what I need to do is, I need to compute what is sigma M, what is sigma A. Sigma M and sigma A. So what is the formula for sigma M and sigma A? Sigma M is mean stress. Here it is bending, mean bending stress. Sigma A is mean amplitude stress. The formula for sigma M is
Sigma
M
maximum.
into mean bending moment divided by Z and
Z. Amplitude bending moment by Z, sir.
amplitude of the bending moment divided by Z. So, but what is this mean bending moment? Mean bending moment is nothing but the average of minimum bending moment and maximum bending moment. So, minimum bending moment is, if I take this position, the minimum bending moment is your M minimum is minimum load, that is minus 50, and the distance is 100 only. So it is minimum bending moment is minus 5000 Newton mm, and maximum bending moment is when the load is maximum, you are going to get the bending moment is also maximum, which is 15,000 Newton mm. So now your mean bending moment is nothing but average of these two, that is 15,000 minus 5000 divided by 2, which is 5000 Newton mm, and amplitude bending moment is m max minus m min, that is 15,000 minus of minus, it become 5 plus 5000 divided by 2, which is 10,000 Newton mm. I know these two values. Now I know these two values. Then what is your sigma m? Sigma m is equal to mean bending moment. Mean bending moment is 5000 divided by 5 by 32 into d cube. So I don't know the d. I need to compute the d value. It is 5 by 32 into d cube. So then similarly, if you want, you can simplify this. Okay, or later we can do it. Your sigma A is 10,000 divided by 5 by 32 d cube. But these are not the maximum values. Why these are not the maximum values? See here, you have a fillet here. Because of fillet, there is a stress concentration. So you need to find out what is Kf. Then you need to apply that Kf to this mean stress and amplitude stress. And also not only that, here he has given the factor of safety. This factor of safety you need to apply for the SE and your SYD also. Okay, we'll come to that. We'll do it one by one. So first what we'll do is we'll try to compute what is the KT. So in our Q is already given, not sensitive factor 0.9 is given in the problem. But I want to find KT value so that I can find out the KF value. So to find the KT value, again we need to refer the data book. In the data book, you need to refer a table corresponding to a stepped shaft which is subjected to bending moment. So in that again, you need to look at another two ratios, that is capital D by small d. That is, this is the capital D is the size of the largest step or larger dimension in the step, and small d is the dimension of the smaller step. So here in this case it is 1.5 d divided by d, which is nothing but 1.5. Then radius of the fillet divided by the small diameter. Radius of fillet he has given it as 0.2 d and diameter of the shaft he has given it as d. So which is 0.2. Now capital D by d is equal to 1.5 and small r by d is equal to 0.2. For these two values, from the data book we need to pick what is the value of KT, critical stress concentration factor. So now what is that value? Huh? What is the value?
1.42, sir.
ఎంత వచ్చిందమ్మా?
1.42.
1.42 or 44. Let's take it as 1.42. Then what is your KF? Your KF is nothing but 1 plus Q into KT minus 1, which is 1 plus 0.9 into KT is 1.42. We got it minus 1. Compute KF value.
1.378, sir.
KF
Yes, sir.
1.378. 1.378. So now you need to apply this KF, that is fatigue stress concentration factor, to this sigma m as well as sigma A, because you have two stresses. You need to apply that one to both. So now if I apply that to the both of the equations, then your sigma m max is equal to KF into sigma m, which is nothing but 1.378 into 5000 divided by 5 by 32 d cube. Now you compute this value and tell me what is this.
70180.96, sir.
Divided by
11,
DQ. 7 0.
70, sir.
7,
Yes, sir.
Yes, sir.
70,
180.96 divided by D cube.
180.96 divided by
D cube.
d cube, Newton per mm square.
Mm square.
Similarly, you compute what is sigma A max. Sigma A max is nothing but Kf into sigma A, which is 1.378 into 10,000 divided by 5 by 32 d cube. To compute this also.
140.
1218.
Sir, 140 వచ్చింది.
Ah?
140361 వచ్చింది సార్.
అదే చెప్పు, నాకు క్లారిటీగా అర్థం కాదు నువ్వు చెప్పింది.
0
140
361.292
361.92 divided by d
divided
cube,
by D cube.
Newton per mm square. So now we know sigma m max, sigma A max, but they are in terms of unknown diameter d. So now we'll use those two equations for the failure. So what are those two equations? The first equation is sigma m by SUT plus sigma A by SC is equal to 1 by Fs. This is one equation. But here sigma m and sigma A both are unknowns. So you cannot get from one equation, you cannot go to both. So the other equation is tan theta. Tan theta is nothing but it is sigma m by. Don't think that sigma m means you have to take this value here, whatever you calculated earlier. You have to consider sigma m max. Even though here I am writing it as sigma m, you have to take this value, sigma m max, and you have to take sigma A max value. So don't think that only sigma m and sigma A are the earlier values. It's not the case. You have to consider the maximum values only. After applying the fatigue stress concentration factor, then only you will consider that one as mean stress and that one as amplitude stress. So that means your sigma m is this one 70180.96 by d cube, and sigma A is 140,361.92 by d cube. So now tan theta is nothing but sigma m by sigma A, reverse, sigma A by sigma m. So that means, so if I divide this one by this, how much I am going to get? I'll get it as 2. If you calculate it, you will get 2. Sigma A by sigma m, you will get only 2. So then what I'll do is, I can rewrite this equation or as is I will take. So then from this what I can write is, wherever sigma A is there, I can write that one as 2 into sigma m. So now you take this equation, in this equation you substitute for sigma A, and in place of sigma m also you need to substitute what is sigma A. What is?
సార్
Yeah.
అక్కడ రెండిట్లో కావాల్సింది డయామీటర్ కాబట్టి కామన్ తీసుకుంటూ వచ్చింది కదా సార్.
ఏంటది? వాయిస్ వినపట్లేదమ్మా ఇది.
అక్కడ మనకి అన్నోన్ రెండిట్లో అన్నోన్ ఒకటే కదా సార్, డిఏ కదా సార్.
రెండిట్లో అన్నోన్ ఒకటే, బట్ యూ డోంట్ నో వాట్ ఈస్ ద రేషియో నా ఇన్ దిస్ ఈక్వేషన్.
ఒక వాల్యూ కామన్ తీసుకుంటే వస్తుంది సార్.
No, in this equation sigma m and sigma A, even though they are in the form of d only, unknown is d only, but the thing here is, if you don't know the relation between these two, then you might have a problem. See, in that whatever I can say, that in that car you have your equation is something like this. So now if you choose some particular point, there is a fixed ratio between the sigma m and sigma A. That is important point. If you don't follow that now, then you may get a chance of a point lying here. You are not, that's what we discussed in the modified Goodman diagram. If you want to include yielding is also into the criteria. So if you take only, so if you are thinking that you are taking that Okay, here the only unknown is only the D only. So I have one equation, one unknown, I can solve for it. Okay, you can solve it, but you need to include this effect also. Sigma A by sigma M ratio also you need to include. If you don't include here, this is the equation for this entire line, right?
Yes, sir.
Sigma M by SUT plus sigma A by SC is equal to 1 by Fs is nothing but your original Goodman line. It's not
Yes, sir.
modified Goodman line. So that means
Yes,
if you
sir.
substitute directly that without taking this relation, what you are going to get is, you will get this line. That means you are not taking into the account of yielding is not considering you. So to take that yielding also into account, you need to use this relation also. That is important thing here. Understood?
Okay, sir.
Right. So here for sigma A, I'll substitute 2 into sigma M in that equation. So now if I do that, okay, I'll write this one. I'll rub up this and I'll try to, anyway, we required sigma M value. So first is sigma M. Sigma M, what is the sigma M value? 7. Derivation, entadi? 70,
70180
70,
180.96, sir.
180.96 divided by D cube divided by
Into
SUT.
600.
SUT is 600. 600 D cube, I'll write like this. 600 D cube plus 2 sigma A. In
2
place of
into
sigma M, you need to substitute 2 sigma M. That is nothing but
2
2
into
sigma M is
70.
nothing but the same value only. This one only you are going to get. That is 14361.92 divided by your SC. We computed SC as 189.16 D cube is equal to 1 by Fx. Factor of F is 2.
సార్ ఇప్పుడు అది చేసిన అదే వాల్యూ వస్తుంది సార్.
Huh?
ఇప్పుడు ఇందాక ఇప్పుడు ఇంటూ 2 చేశారు కదా సార్,
Yes.
అది చేసిన కింద సిగ్మా వాల్యూ అదే వచ్చింది కదా సార్.
అది చేసినా
2 సిగ్మా ఎం సబ్స్టిట్యూట్ చేసిన.
ఓకే బట్ దిస్ ఈజ్ ఏ స్పెషల్ కేస్ హియర్ ఆల్వేస్ యూ మే నాట్ గెట్ లైక్ దట్. ఇక్కడ ఏంటంటే మీన్ అండ్ యావరేజ్ 2 times ఉంది. ఇక్కడ ప్రతిసారి అదే ఉండాలని రూల్ లేదు. ఇన్ దిస్ పర్టికులర్ ప్రాబ్లం యు ఆర్ గెటింగ్ లైక్ దట్. కోఇన్సిడెంటల్లీ ఇట్ ఈస్ హ్యాపెన్ టు బి లైక్ దట్. Sigma M and sigma A ratio is 2 here, but sometimes it may not be the case.
ఓకే సార్.
Because here load 50 and 150, minus 50, 150 is given. So you are getting mean load is 50 and amplitude load is 100. Instead of that, suppose if I given it as 25 and 150, then what you are going to get? 25 and 150 means if you take 75 1, then 150, 175 by 2, 75 by 2 and 175 by 2. So you are not going to get that as a same.
ఓకే
You
సార్.
get a different value. Maybe incidentally for this case it is happened like that, but always it is not the case.
ఓకే సార్.
Okay. Now you solve this one. From this you will get the D value.
లెవెన్ పాయింట్ 97 వచ్చింది సార్. డి
11.97.
97.
Yeah, man. Okay, so this is how we can solve it. But okay, if you take d value and substitute in the value expression for sigma a max, that means 140,361.92 divided by d cube. In place of d cube, we take it as okay 11.97. I'll take it as 12 mm. So substitute d is equal to 12. Then tell me how much you are going to get the sigma a max. Here, in the expression for sigma A max, we got it as 1,40,361.92 divided by d cube, Newton per mm square. So now we calculated d value as 12 mm. You take the d and substitute into this and tell me what is the value of stress.
సార్ సిగ్మా ఎమ్ 40.61 వచ్చింది సార్.
Sigma m,
ఎస్ సార్.
sigma m akkarledam manaki. We want sigma a only.
Sigma 81.22.
Huh?
81.22.
60?
81.22, sir.
81.5 ah?
22, sir.
Okay, whatever maybe around 82. See, now the sigma A is only 82. What is your SE? Your SE is 189. So that means if you take the D as 12 mm, what is the life of the component? It is infinite. So that's what when you say the component will have infinite life, if the magnitude of the amplitude stress is less than SE, then the component will have infinite life. If the magnitude of your sigma A is more than SE, then it will have only finite life. So now here you are getting sigma A as 81 MPa, whereas your SE is 189 MPa. So that means your component have infinite life. Like that I can check it. Or else the same problem you can solve in another way also. What is the other way of doing it? So here, instead of substituting for the sigma m and sigma a, what we calculated here, what I can do here is simply I'll calculate instead of stresses here, I'll take these equations as something Sm and Sa. That's what we are taking in the data in the modified Goodman diagram also. Here what we'll do is I'll take Sm and Sa, and here also instead of sigma a and sigma m, what I'll do is I'll take Sa and Sm. The ratio of strength, these are the strength. Earlier we are considering the stresses. Now we are considering the strength of the material. So that means here we are not going to apply even this factor of safety also. So what we'll do is I'll take this one as 1. Sm by Sud plus Sa by Se. In this I don't know what is Sm and what is Sa. But I know the ratio of Sa by Sm, which is nothing but again 2. So now, okay, I'll show that here. If I draw on the diagram here, anyway, this is now done. We'll come to this later. So now, if I take that modified Goodman diagram, it is something like this. If I draw a line here, if I take this point, then the strength corresponding to, or if you project this point onto this, you will get Sa, and if you project this point onto the horizontal axis, you will get Sm. I want to compute the strength values. So once I compute Sa value also, then I can calculate the diameter, or once I take Sm value also, I can calculate the diameter. Based on Sa and based on Sm, I'll get two different values. Out of those two, which one maximum I need to take? Generally, we'll consider Sa. Based on Sa, we can design the component. So now, to do this, what I'll do is, instead of taking sigma m and sigma a, what I'll do is, I'll try to find out what is Sa, Sm. Then from the Sa, I'll take Sa. For infinite life, the only criteria is your Sa should be less than or equal to your Se by Fs. You take the equation something like that and you can solve for that also. So now, if I want to solve in that approach, let us see how much what is the answer we are going to get for that in that approach also. That means here I am taking Sm by Sut, Sa by Se equal to 1. So from this relation, Sa by Sm is equal to 2. I can write it here. I'll write in terms of Sm. So from this, I can write your Sm is equal to 0.5 SA. So now I'll take this and I'll substitute here. Wherever Sm is there, I'll substitute 0.5 SA divided by SUT is 600 plus SA is nothing but SA. I'll keep it as SA itself. Divided by SC, we got it as 180,
189 point.
189.16, which is equal to 1. Now in this entire equation, the only unknown for me is only SA. So now you solve for SA from this equation. Point 0.5 SA by 600 plus SA by 189.16 equal to 1. If you solve that, you will get SA value. So, okay, you do it later, I'll tell you. What is this SA, what is its significance also, I'll tell you. ఎంత టైం పట్టింది సాల్వ్ చేయడానికి SA by 1200 plus SA by 189.16 is equal to 1.
163.40, sir.
1263?
163.
163, okay. 163.44
0.40.
MPa, because your SA, SUT, SY, SER and MPa, here also you will get it as SA. Okay, so now this SA value, whatever I got it as SA, I will call it as equivalent endurance strength of the component when this component is subjected to simultaneously mean stress as well as amplitude stress. Earlier we defined only the fatigue strength or endurance strength for a completely reversible cycle. That means when the mean stress is 0, then we are taking SA as the criteria to estimate the life. Similarly here, this SA is nothing but equivalent to that. That means here this component is subjected to both mean stress as well as amplitude stress. But what I am doing is, by considering this equation, I am converting this mean and amplitude stress into a single stress, which is amplitude stress, whose magnitude is, or whose endurance limit is going to be 163.44. So that means actually we calculated SE value here. That SE is different. Even this SA is different. So why it is different? Because SA is, this is the value of SE what we are getting because of the effect of mean stress also. Earlier whatever SE calculated here, that is because of working conditions of that component. Now I'll take this. This is the, I'll consider this one as the endurance limit. So then your SA, your design equation is going to be SA should be greater than or equal to your sigma A max. So then, since SA is greater than sigma A max, definitely the component is going to have an infinite life. So now you substitute what are the things you got it. So 163.44 is equal to, what is sigma A max we calculated here in terms of D. What is that value here?
KF into sigma A, sir. KF into sigma A.
140.
361.92 divided by D cube.
361.92 divided by D cube. So in the limiting condition, I am saying that SA should be greater than or equal to sigma A, and the limiting condition I will take it as equal to. So now we solve this. From this you tell me what is the value of D you are getting now. Two things here. Earlier case what we did is, first we computed the D value, then we computed the sigma A max value, and then we compare SC to entrance limit, then we identify that whether the life is infinite or not. Now in this case what we are doing is
9.5 వచ్చింది సార్.
huh?
డి 9.5 వచ్చింది సార్.
9.5 చెక్ చేయ ఒకసారి క్యాలిక్యులేషన్ అన్ని కరెక్టే కాదా?
ఎస్ సార్ 9.5 వచ్చింది సార్.
No, I don't think so. It is also close to that 11.9 thing ఏదో వచ్చింది కదా, దానికి దగ్గరలో రావాలి. If you need to check your calculations.
చాలండి.
ఎస్సీ అయినా చాలా ఎక్కువ వచ్చిందమ్మా నీకు. ఎస్సీ 163, ఇది కరెక్టేనా? దీన్ని వెరిఫై చేయి. This is anyway earlier one, this is not changed, only SCA you need to check. So this one,
$163 వచ్చింది సార్ అది.
163 అంతేనా?
ఎస్ సార్.
Okay, so is 163, ఈ value correct. Then in that case, ఈ D calculation కూడా correct, 9 point something.
ఎస్ సార్.
So I don't think so. Why you all get it? Maybe both should be close enough. Now it won't deviate this much. Anyway, I'll check the calculation, and next class I'll tell you that why you are getting a deviation between those two. I'll verify. After that, I'll tell you the solution also.
ఓకే సార్.
I'll do the calculations, then I'll check it, and then we'll discuss why you are getting the deviation also. Maybe some factors. So rounding off factor, even those factors are same everywhere. It is their same only. Nah, why you are not getting the same value? We need to get the same value. Anyway, so that is one way of solving the problem, and this is the other way of solving the problem. So you can do in either way you do it. Maybe you will get a slightly different answer, but not that much difference. So only deviation in the answer should be around 2% or 3% or maximum 5%. You won't get more than that. Here, if you get a 20, in the other case, other method, you need to get either 22 or 18 or something like that. So within that range only, you won't get more than that. Okay, so this is how you need to solve the problem when there is a bending load and the component is subjected to fluctuating stress. Similarly, we discussed one more diagram for modified Goodman case when the load is only torsional sphere. So this approach is valid for when the load is either bending load or axial load. If the load is either axial load or bending load, we'll use this approach. Suppose if the load is torsion, that means the component is subjected to torsional shear stress. In that case, in the previous class we already discussed that also. The mean stress don't have any effect on the endurance strength. So we need to solve for only the component based on endurance limit only. So we already draw that modified diagram also. The modified Goodman diagram for torsional shear stress, it looks like this. This is the yield line and this is SE constant line. This we already seen that. I think we want to take up one problem on this also, so that it is completed and we can close this topic. Okay, maybe we have only 2 minutes time left in this class. In next class we will take up that problem. If you have any doubt, then you can ask now. If anybody having any doubt, then you can ask. ఆ రూల్ అవి పని చేయట్లేదు శేషు, మైక్ అని అయ్యి ఆ రూల్ ఇవి ఉన్నాయి కదా, ఏం పని చేయట్లేదు సిస్టమ్, మరి ఏదో ప్రాబ్లం వచ్చింది దానికి ఆర్పి చెప్పు ఒకసారి. ఇది కాదు ఆ రూమ్లో 20 నిమిషాలు నేను అటు చేసి ట్రై చేసి వర్కౌట్ అవ్వక ఇక్కడికి వచ్చా. స్పీకర్ కనెక్ట్ అవ్వట్లేదు, కెమెరా కనెక్ట్ అవ్వట్లేదు. ఒకసారి ఆ? ఆ. ఆ. పెట్టాగా నేను పెట్టాగా రాలా ఆ. అదే నువ్వు పెట్టినప్పుడు వచ్చింది, కానీ నేను మాట్లాడేది వాడు స్టూడెంట్ కాలంలో వాడు మాట్లాడేది నాకు వినపట్ల. అలా వచ్చినాయి. కెమెరా రావట్లా, స్పీకర్ రావట్లా, రెండు ప్రాబ్లమ్స్ చెప్పండి. ఓకే. ఓకే అమ్మా, ఇఫ్ దేర్ ఈస్ నో డౌట్స్, దెన్ ఐ విల్